So this is the CDS session for Pacific and for RBD. Sage is going to be joining a little bit late. They said just to go ahead and get started. In the chat window, I pasted the link for the pad for the CDS. Scroll down, there's a RBD section under Thursday, April 2nd at 1400 UTC. I pasted a few things there, some of the bigger items that we have on the Trello board, on the Ceph backlog, things that we can probably start looking at for Pacific. I don't see Ronan, so I'm just going to skip over the RBD snapshots with Cal radix tree because I have no idea what that is, unless someone else here knows what that is and can speak to it. Going once, twice. All right, I put the KRBD features at the top. It's not obviously tied to Pacific release, but these are things that I know are going to be worked on, at least, or I'd like to see get worked on during this development period. Ilya's on the line. Talk to any of these. I know he's working Messenger v2. That's not RBD specific. It'll help StuffFS and RBD. If there's anything you want to talk to on that, Ilya, or everything's pretty much in hand.
Yeah, nothing
Yeah.
to add. Work is ongoing and will be done in the Pacific timeframe. So even though it's obviously won't be released as a Pacific deliverable, it's still something that at least will be moved in the Trello board into the Pacific column when it's done. So from that point of view, it's a Pacific item.
So the next item, it was something that we added librd late in the octopus cycle. The first one was compression hints. You can specify on individual RBD images or on RBD pools to say that these images are incompressible, and it sends that hint to the OSD so that if it's got aggressive compression settings, it won't even attempt to compress it. Or if you say that this is compressible, if it's got OSD settings that say, try to compress it, it'll be more aggressive about attempting the compression on it. So this is just something that hopefully we can get those hints passed up via the RBD CLI to KRBD so that KRBD can send those hints on write IOs to the backing OSD. And the localized read hints, that's something that's kind of actually more towards libceph, but the same thing where you can specify hints on an image to say, hey, do a localized read. So based on my crush location of XYZ, find the closest PG and send the reads to that. That was a late stage octopus change to the OSDs to support that from safely reading from non-primary PGs. librd had supported things like that before with either read-only parent images and also from read-only snapshot reads. So this extends it towards the actual head revision of the object. The use case here being for stretch clusters, where you might have your OSDs in different data centers. You want to try to redirect all reads at least to the closest data center from where the workload is running. I'm going to pass the ball back over to you, Ilya. Is there anything else that you can foresee coming in the next year for KRBD? Or anything you'd like to work on?
Yes, for KRBD specifically, I would like to get at least some of the async refactoring done. This concerns the exclusive lock code, which is the last remaining synchronous piece that sometimes gets on the way of the asynchronous I/O path that we have, and kind of tied into that because exclusive lock depends on on being able to properly refresh the image header and do notifications on it. That kind of ties with the initial, RBD map sequence for opening and mapping the image. That's also synchronous, and it could have remained so, but because the exclusive lock ends up using some of that code, it will need to become asynchronous as well. This stands in the way of features such as block layer level timeouts, so that you could set a timeout, for each request, and it'll be timed out by the block layer, as opposed to the sort of big hammer that we currently have in libsaf that can time out the OSD requests only and nothing else. And the problem with this, again, while it kind of sort of works for just regular I/O, as soon as you get stuff like exclusive lock involved or any of the, like, basically, as long as you deviate from a simple image that doesn't have any parents, no parent chain, and a very simple object layout. So pretty much just the default object layout, with the only variable that can be changed is the object size, so no striping. Under those conditions, the timeouts through libsaf will work, but for everything else, we need for the timeout to come from the level above the RBD driver, because otherwise we just don't know what to time out because we have no idea what's in flight. So while that feature is, we haven't seen any customer or user requests for it. That's probably nice to have. And the second thing that ties into this, which is a kind of timeout, except that a forced timeout, it's the forceful unmap of images that are for some reason stuck. Currently, we don't do this because, again, we don't know what's in flight because once, say in the exclusive lock state machine, once a particular thread gets stuck because on a synchronous call to the OSDs, it's very hard to cancel it. And refactoring so that everything is asynchronous would obviously solve that. So those are the two kind of features that depend on this. But even if we don't end up implementing them, the asynchronous refactoring is something that is pretty much at the top of the list now, because any further development would probably depend on it, because I keep bumping into the issues associated with this, such as locks held in inappropriate places, and the possibility of the thread getting stuck for an indefinite amount of time when exclusive lock feature is enabled. That gets more and more in the way of future plans and development, whatever that might be. I'd like to spend some time working on that. I'm not sure if we get all of it done, but there are some subtasks that are relatively low hanging and can get us at least halfway there. Yeah, that's the big ticket item. There are some other smaller things. One thing I wanted to consider, again, this is and this one is not specific to RBD. This is a libsef item. There is now a cache in Liberados that caches crush mappings. And so it's relatively self-contained. And if my calculations are right, memory the memory usage is acceptable for the kernel, and we can bring that in and hopefully shave off some CPU cycles on small workloads. That's it.
So is that caching like the object ID to crush hash you're talking about? Like what is that cache?
No, the object ID is computed. It caches the hash. Basically, it caches the mapping of the PG so that we don't have to. When we get the PG, we don't have to calculate the OSDs, right? So we don't invoke the crush algorithm. We do everything else, but without invoking the crush algorithm. And we obviously invalidate the cache on any OSD map changes.
Any updates, yeah.
Yep.
All right. Thank you for that. Moving on, the next item I had on the list is, while RBD focused, it's actually the implementation would go inside of W. I spoke to it briefly yesterday. The goal being that RBD snapshots are essentially giant immutable objects, so why not expose them to the giant immutable objects they are via RGW? And this would basically be, as I was told, with the new zipper plugin layer, codename zipper plugin layer of RGW, we can create a new basically provider, which is a RBD provider, the buckets and the objects within the buckets. Any RESTful calls to RGW for those buckets can get translated down via this zipper layer and zipper plugin to the associated librd calls to read and write RBD images. The goal being exposing snapshots in both a raw fashion, so like the full block device, and also the permutations of snapshot deltas. You can just get a thin snapshot delta exposed. And again, it's all programmatically exposed. It wouldn't be copying any data from RBD images into an RGW pool or anything like that. Yeah, that's pretty much it. The one caveat also is that the snapshots that we want to expose, those differentials we want to expose, and also probably also the snapshots that we expose via the current RBD export commands and export diff commands, we're going to want to make sure those are at least a unified format, so not just reinventing the wheel again. And we're also going to want to extend that diff format so that we can also include an optional set of indexing, which will actually tie into the next feature, which is the instant recovery from an S3 or Swift-backed RBD image. So the goal with this is essentially we already have support for cloning images. Nautilus added support for live migration, which is an ability to create a new cloned image per se from an arbitrary parent image. So in the case of instance recovery, instead of that parent image being a true like lib or true RBD image, we could embed an S3 or Swift client within librd and satisfy all the reads for that parent via that S3 or Swift client endpoint. Create a new image, you'd basically be able to say like, hey, this is a new, import this image or whatever, start an instant recovery from this S3 endpoint, provide the credentials to talk to that S3 endpoint, and go. And so when the image is first opened, there's obviously no data there. Any reads that would be satisfied would be redirected towards the S3 Swift endpoint. But then they can also start doing things that live migration does, which is rehydrating the local, the new cloned or what have you image, instant recovered image. So in the background, we can have a process that is just reading and writing, essentially copying up the data from the S3 or Swift endpoint back into the RBD image, so that eventually, just like live migration, we can eventually sever the link between the S3 Swift endpoint and the RBD image. So this is just a transitory state of how to get the image back in. It's going to be pretty trivial to support raw images to start with, and then snapshots. As I mentioned, if we extend our current snapshot diff format to basically append on some indexing so we can know how to look up or where to look in the data stream for particular offsets, we should be able to support snapshots as well. Any comments, questions, or concerns about anything talked about so far from anyone?
So will RBD depends on S3 clients, Swift clients, or how it's?
I think, yeah. So yeah, in a perfect world, we could probably implement that as an optional plugin, so we don't bloat the size of librd.
Because I think another approach could be, because we need this tool, I mean migrator or something like this, it's maybe even RBD CLI or something like this, so it start migration and it could be work as a proxy. So in the migration header of this new image header, it could add just endpoint to itself.
Oh yeah. Sorry, that's the goal. Is that when you start that migration, just like with live migration, we say here's the parent.
Yes, but you want to insert the endpoint of this S3 for yes, but you could insert endpoint of this migrate tool. It could be work as a proxy, and we would have our internal protocol. So it would be just sync for this tool, migration tool. Just that would start this migration process to provide this access.
Well, I mean that. So if I understand you correctly, I mean, let's say I have a QEMU librd client that's reading this instant recovery VM disk. Now you're saying that it could basically have a proprietary connection to some proxy process somewhere that then proxies it out to S3 or Swift endpoint.
Yeah.
Because there's no existing protocol. I mean, besides like just the generic Ceph protocol, but you would have to come up with all new messages that go back and forth between librd and this proxy layer to say, for
Yeah,
IO
yeah.
requests. Is your concern like the accessibility of the potential S3 endpoint from where the librd client is running, or the concerns, or
It's probably just so we need to add these dependencies to librd.
so it's more about the bloat of like,
Different implementations. If it's going to be like a plugins, then dynamically loaded, probably it's not a problem. Like we have with Azure coding plugins.
yeah.
I don't know only what credentials we need to store and position point, and if it's from security point of view. So if it's okay to store a secret case, we need, I suppose, need to store in the header of the image.
Yeah. Yeah, so long as sorry. We can possibly get into like the ability to add inject secrets via librd, but I think for a straight up simple implementation, if you were concerned about access, you could always use your object stores, ACLs to restrict access to a particular file based on a particular set of credentials, at least in the short term.
Okay.
Things are changing color and I don't know why. All right. So yeah, the next one I had down was the new Librados ASIO interface. That's like a thread pool and basically like one potentially faster IO handling than the current Librados completion style callback handler. It would just be interesting to benchmark to see if we get any performance improvements on the IO path for high queue depth, high throughput, or high app workload cases. Octopus release, we incorporate a bunch of changes that drastically increase the throughput of librd and brought it way closer to KRBD in terms of performance. But yeah, if we can narrow that gap even more, or potentially narrow the gap, or while reducing the CPU usage, that'd be, I think, a real win for librd. IOPS per CPU. All right, assuming no comments on that. The
Hey,
next.
Jason. Hi.
Oh, yep.
We're interested in this integration work. So I was wondering, like, are there any known bottlenecks or existing issues that might come in the way while we are trying to get that PR in and do the librd integration work? Because I remember you bringing up some RBD export bug, I think, which was, something that's to do with enabling multiple RBD threads, and a bug I'm not talking about the one that's existing currently that is in Crush. I'm talking about something that you brought up a while back.
Yeah, that one had been fixed a while
impact.
ago. Yeah, and got backported.
So is that fixed?
Yeah, so the RBD export command, it handles the proper right? You still have.
Let me,
Are you talking about the one where we don't want to allow
right, yeah,
librd clients to have concurrent callbacks, and that one still exists.
correct.
And
Yeah,
that's what
yeah,
that's
that's the
going to
one.
put on, because I mean the contracts that we have with all legacy librd
Hmm.
API users is they shouldn't expect to have um, concurrent callbacks from us. But we have that other interface, which is the event uh, FD, like a socket notifications and things like that, where
Right,
they could pull and get multiple events back concurrently instead of having us call back into them.
right. But the goal is to have to change that, or to have another option with the SIO
Well,
PR,
so
right?
the ASIO would be internal to librd, at least
Oh,
existing
okay.
clients.
So you're not going to expose the API. Okay.
Not until there's a good use case for a user for that, and I don't foresee that happening anytime soon. Like QEMU is not going to rewrite themselves to say, hey, we're going to use ASIO as our, internal
Mhm.
event driver. But I'm not sure about the value add there, but if we can drive more IO through Librados and get better
Okay.
performance
So
between that layer, it'd be great.
right. So are there any? Do you have? I mean, are you aware, or do you know of any current issues that that we are to expect after if you want to work on, say, this integration work? Are you already aware of any bottlenecks that we might face if we work on it, if we start working on it after the PR merge of ASL?
No, not at the moment. No, I mean,
I think I'm trying to estimate like how much of a workload is it going to be, or how long is that supposed to take?
I don't know. That's why it's yeah, I don't know.
Okay.
I might be thinking about something completely different, but I think we already have, a poll-looking interface in librd. This is how I added many years ago.
Yeah, we have the event FD socket
Yeah,
interface.
yeah. Oh, that's what you meant by okay.
So we have the polling interface already, and we have the callback interface. The callback interface, we can't violate our existing users' assumptions that they're not going to get concurrent callbacks. But if you wanted to potentially drive more from the librd client's point of view, if you wanted to potentially pull and drive more IO through librd, there's the event socket interface. It may not be optimized, and there may be some things we can do to tweak it and make it better, but I think that's the starting point. I mean, QEMU itself has a single thread that handles all block IO requests. So at a certain point in time, we get to we move the goalpost to the next bottleneck down the line. All right. Assuming nothing else on that one, the next one down was the librd persistent write-back cache. So that's an Intel effort, and it's still moving forward, and I presume it'll be merged for the Pacific timeframe cycle. So that's the ability to carve out a section of some fast flash on a librd client node and have that be utilized as a fast persistent write back cache, so potentially very large in size. And should the client crash and be restarted, it can replay from its cache to get that data injected back into Liberatos. Any comments or questions about anything so far? Anything else?
I just want to add that we're also working on an SSD implementation that we'd like to be through Pacific. So I think the one that's being upstreamed is for AB, the persistent memory module.
Yeah.
Yeah, we're also parallelly working on like a different API, or rather trying to integrate the SSD version with this. I mean, we're working internally and we're trying to push it upstream this for the next release.
Okay, great. All right, so the next item is the coordination of snapshots creation and freeze-thaw cycles on the associated clients that are potentially running workloads on the image. So this is because your workload that's actually reading and writing to your RBD image could be running anywhere technically, compared to where someone runs the RBD snap create command. We wanted to offer a way that smart enough clients could notice that a snapshot's about to be created. They could do something to quiesce or freeze their file systems that are running on top of, or workloads running on top of RBD. Snapshot could then be created, and then they could be told to unfreeze, quiesce the block device. So RBD MBD is one initial hook point where we can send the IO iactals for FI freeze and FI thaw on the block device. Other examples could be QEMU, or if we modified the RBD block driver there, we could potentially send something to the QEMU guest agent running inside a VM saying, hey, we're about to create a snapshot, freeze or thaw. That's obviously outside of our control, but if there's enough time, we can maybe submit something upstream to say, hey, here's an example of how you could implement this or merge this into QEMU if it's acceptable. It would also be nice if we could get something semi-equivalent into KRBD, so when KRBD sees these messages coming, it could, at the worst case, the simplest case, just kind of follow the FI freeze, FI thaw iactal path, maybe even better if it could, and I don't know how, but if it could do something to help coordinate application level freezing and thawing in user space, send some type of notification out. They don't have any comments or questions about that item?
Just on the KRBD front, this would obviously be considered a layering violation, and like no one's going to be happy about it. But I think there is a precedent for something like this in the device mapper.
Like if you're saying if your block device basically injects
if you're a block device and somehow you get wind of that a snapshot is about to be created and you want to freeze the file system that's running on top of this block device, that's obviously not how not how things are intended to work. But like I said, I think there is precedent for something like this in the device mapper. So that's just that's something to take a look at and do a bit of research there, because if it might be tied to the device mapper core.
Mhm.
But the fact that the fact that there is precedent for this is is a big thing, because it will allow us to do something similar. If we can use that code, do something similar on our own, because and in case somebody asks, point to the device mapper.
Yeah. Okay. Yeah, and I also didn't know if there's like another way you could just like, upon receiving this notification, you could like send some type of message or whatever back down to user space to say, hey, if you care about it, now's the time to freeze. On any application you want to freeze it. I'm seeing you through like a UDEV notification. That's just like a one-way pass-through. So if someone's listening to it, but that doesn't really necessarily help you.
Well, I think a few years ago we talked about like a two-phase or three-phase commit or whatever process for taking snapshots, because currently when somebody types RBD snap create, and if the client doesn't ACK the header refresh notification,
yeah, they keep changing their snapshots.
After 5 seconds, the snapshot is still taken, and the client can. I think there is nothing preventing a client to still do some of the writes that were queued with the old snapshot context,
Correct.
and basically corrupt the snapshot.
Yes.
So I think we need something like a two-phase commit for two-phase commit procedure for snapshot creation for fundamental snapshot safety reasons, and we could tie the request to freeze stuff in it, and then we could potentially, if all else fails, do the freeze at the driver level. So just flush the stuff that we have in flight, and then just tell the block layer that we're not going to be accepting any new requests for a while. There's a way to do that.
Okay.
But we obviously need this cannot be just like a random notification that times out after 5 seconds. This needs to be a proper two-phase commit.
This is if it's going to send out on the header, it's going to send out a message saying we ask or freeze, and everyone has to ACK it. That supports it. Everyone that doesn't support it will send an EOP not supported, so we'll just ignore those clients.
Right, and we need to extend that to not just the freeze, but also to the act of like publishing a new snapshot context, basically taking a snapshot. So if there is a client that doesn't ACK, we need to fail the snap create, unless could probably add a force option, and the users could then retry with the force option if there is a misbehaving client. But I think if we were going to do some surgery on this code path, addressing this long-standing kind of this is basically a data corruption issue to some extent. So addressing it, I think is like we need to do that.
Well, we can certainly like on the API. When this first releases, there'll be like no clients that will support it, so I wouldn't want to change any default behavior. It says fail snapshots if clients respond with EOP not supported. But if we had some type of optional on the CLI and via the API to say, what we ask, mode you want, like, required or, best effort, type of flags, and one day in the future we can change the default from best effort to required until someone says, and then uses the CLI to say, don't care. So, something along those lines.
Makes sense.
Okay.
New API for snap create. Yes. To pass the flag.
Yeah, it'll be yeah, like a new RBD snap create API that you could pass some flags to. Wrong, but... Okay. Moving on, so the RBD MBD daemon, we still have in our plans that we want to be able to have an optional mode of RBD NBD where it's a single daemon that serves multiple hosts or multiple block devices. Right now, it's a single daemon per image that's being served, so it's like a one-to-one tie between a dev MBD device and an RBD MBD daemon that's servicing it. For the use case of Kubernetes and containers, we need some way that we can, right now, if inside the Ceph CSI, if you're using the MBD, RBD MBD device, it works until it doesn't, because if you do something like restart the Ceph CSI node container, all the daemons that were running inside of it get killed, and there's no smarts or intelligence to restart those daemons. So the major goal that we need to solve here is we need some way that where we can provide the ability for, number one, for multiple block devices to be serviced by a single daemon, but also that single daemon can recover all its block devices should it be restarted. So the CSI level will probably move this new like combined daemon out to its own container pod so that it has its own lifecycle, not tied to the Ceph CSI RBD node plugin, because otherwise nothing will know to start it until the next application requests a brand new PVC to be mapped on the node. And right now, when the RBD MBD exits or quits, it kind of like tells the kernel to force unmap all the block devices, which just causes IO errors, and it fails all your mounts. So we want something there. If it crashes or if we restart it, any IOs that were in flight get retried, and it doesn't actually kill off the block device. Do you have anything to add? Mike has been working on this. Been distracted lately. But do you have anything to add, Mike?
No, I don't have anything else.
Okay. Assuming no comments from anyone else on that. The next one is librd with client-side encryption. So right now in QEMU, you can layer. QEMU has its own LUX layering support where you can layer LUX on top of QCOW2 or layer it on top of RBD or what have you. But the problem that doesn't solve is the use case of RBD cloned images, because if you layer LUX on top of, if you have LUX already encrypting a parent image and you clone it, you either need to share the exact same crypto information, like the passphrases to unlock the master key and the same master key for the cloned image. Kind of, unless all your golden images are your own copy of a golden image, kind of defeats the purpose of the encryption. It's also sharing the same initialization vectors for the encryption, which opens up chosen text attack vectors and things like that. But if you wanted to be able to say like, oh, I can take a encrypted golden image and make it my own encrypted child image, well, then that means that you need to then basically fully copy the child image, so you can fully re-encrypt it with your new master encryption keys and new IVs, which potentially wastes a lot of space. So the goal with the client-side encryption is to provide a thin encryption layer where the only things that get encrypted using where each cloned image gets its own potential master key in IVs, and we'll have to have some APIs into librd for injecting secrets every image in the chain. And
what if we provide ability to pass parent image to open the, I mean that it would be a responsibility to the client. Well, we can open this image with encrypted parent, but I/O wouldn't work until we pass, so the client need to open parent image and then pass its image context via IP to this children child image.
Yeah, to basically externalize, but then you would need callback hooks for all the I/O that would need to yeah, you could do it that way. I was just thinking probably the easiest way would just be the ability to inject secrets via librd. So you can say imagine a QEMU setup and you define, all right, here's my parent secret to unlock, here's the passphrase to unlock the master key for the parent image, and here's the secret to it, unlock the master key for the child image, and as part of the bootstrap process of the QEMU RBD block device, it just it can do a RBD it lists the parents or whatever in the hierarchy, and then for each of those parents, it can go and find the necessary keys and inject them in. That librd itself can do all the encryption itself. And the other facet of this would be creating a snapshot on an encrypted volume. Again, if you don't create a new initialization vector, it exposes you again to chosen plain text attacks. So the goal would also be somehow to, every time you create a snapshot, to create a new initialization vector that you use from that point forward for any new incoming writes. But if you read for something that was created at snapshot version X, you need to use IV version X to decrypt the data correctly, because that's the IV it was used when it was created. I don't quite understand. I don't have a solution yet for how to do that snapshot initialization vector management, because I think it gets pretty complicated when you create and delete snapshots. You don't know if that object was initially written with a snapshot that has since been deleted, but you still need the IV for it. So how do you store that data permanently without potentially boundless growth of IV storage? But yeah, that's the goal. So space savings, so cost translates to cost savings. Yeah, just trying to avoid having to fully re-encrypt everything when you create clones or create snapshots. Any other comments on that one?
What is the use case? I mean, I see what it solves, but do we actually have people asking for this?
Yeah, we have people asking for it. Yeah.
And why using why encrypting the entire store? Why they're not encrypting just at the blue store level? Because the IV management is very easy to get wrong, and especially when we get into the snapshot territory and having to sort of segment the IV space between the snapshots. and the fact that this is not that this is encryption at rest as opposed to just in-flight encryption. Encryption at rest is even harder to get right. So
Well, yeah,
I'm
because
just not.
the OSDs get it wrong, right? Because they don't give new IVs for their snapshots, so you can plain text attack
Right.
the OSDs as well.
Right. So this seems to me like we were working on this at the wrong level because there's nothing there's nothing to be gained from doing this in LibRBD because we don't have unlike for example with mirroring where the generic radius based solution was just too unwieldy. Here, it seems like the problem space is exactly the same, and it's like exactly the same objects with exactly the same, snapshot context. And I just don't see the point of doing this at the RBD level.
Yeah,
maybe.
I think the people that are requesting it are the people that have legal reasons why they need to basically say that we are in control of our encryption keys and not some unknown third party storage vendor that's potentially encrypting it, but we can't prove that they're encrypting it on their OSDs. But if we say that we're in control of the keys, then we can control the key life cycles and things like that, like compliance and things like that.
I'm not sure. I'm not sure that argument stands because if you don't trust the OSDs to encrypt the data, then if you don't trust your storage system, then why would you trust a LibRBD library, which is part of that storage system, to encrypt the data?
Get back to key management though. I mean, there's certain compliance requirements why tenants would need to control the keys and the key life cycles and things like that. And if you have one set of keys that controls the OSDs, that it doesn't give that ability to the end users. It's the same reason why RGW supports encrypting objects at RGW.
Yeah, but the RGW use case is much simpler because the objects are immutable.
Yeah. Yep. But it's the same compliance reasons why people ask for it.
All right.
Yeah, and the only other thing I had on my list was just a blank space for Mike. iSCSI improvements that we can foresee coming down the pike.
For this one, I just have my failover failback. So basically just fix that problem with the lock bouncing we have the two cases, the one where we have the misconfigure, and then the one where operating systems discover the paths in different orders. And then when the active optimized path fails, the different hosts fall over to different active non-optimized paths. And so I've just been working on the fixes and improvements for that. And I think for iSCSI, that's probably the major thing and only thing I've really been working on other than just trivial bug fixes.
That's all I had. Talk through. I mean, there's some other items that are real in the Trello board that anyone is free to review. The Trello board is here. Is there anything else anyone wants to talk about in the last few minutes? I know one that's always always like every release is on our list, which is RBD mirror consistency check, but that's still, and of course, Sage never joined, but it's still dependent on Rados features that are not available yet. So that one's perpetually blocked. Yeah, that's all I had to talk about. Again, if the floor is open to anyone else for the last couple minutes. All right, well, in that case, I'll I thank everyone for joining. I guess this concludes the RBD portion of the Pacific CDS. Thanks all.
Thanks. Bye.
Thank you.